Understanding binary search.
This is a fast way to find an item in a sorted list by repeatedly dividing the search range in half. It's efficient, but only when implemented correctly. Knowing the common pitfalls can help ensure your code is both accurate and robust.
Incorrect midpoint calculation.
A frequent error is miscalculating the midpoint index. Using low plus high divided by 2 can cause integer overflow. The safer formula is low plus high minus low divided by 2. This small change helps prevent subtle bugs, especially with large arrays.
Infinite loops and incorrect boundaries.
Failing to update your search boundaries properly can lead to infinite loops or missed elements. Always make sure to adjust low and high correctly after each comparison. Double-check if your algorithm should use inclusive or exclusive bounds for your use case.
Assuming the list is always sorted.
Binary search only works on sorted arrays. Applying it to an unsorted list leads to unpredictable results. Always validate or sort your data before running binary search to avoid unexpected errors or missed targets.
Handling duplicates improperly.
If the array contains duplicates, standard binary search may not locate the first or last occurrence of a value. To find these positions, modify your approach by continuing the search after finding a match, moving towards either end as needed.
Overlooking edge cases.
Common binary search bugs arise from not considering edge cases, like empty arrays, single-element lists, or targets not in the data. Always test your code with these scenarios to make your binary search more reliable and robust.